Hi. Do we need to switch the input for the projector? Apparently he's giving video out, but we're not getting anything on the projector.
Is it HD?
I think he's using VGA.
Okay.
Do we can we switch? Or?
Yeah. You have it's number 2. So if you want an HDMI, you pull that down. But if you want VGA, you pull that down.
Okay. Mm-hmm.
It's the VGA. You didn't pull that down.
I don't think he was using VGA. I think he was using DisplayPort.
He said he was using VGA. Okay, let's have a check. Yeah. Okay, but we. Okay.
So that's probably one of the problems. So next time somebody comes and uses HDMI, pull that one down.
Right. Thank you.
Okay, so we're ready to start. So Emabella is going to give us the fourth talk running on the CN graph in GTK, but it's looking pretty good. So let's go.
Hi everyone. Yeah, you should be able to hear me now. So, welcome back to the annual therapy session that I hold at GUADEC for myself. Yeah, you'd be like me if you had to deal with this stuff. Let's see. Yeah, this is actually the new incarnation of the usual tradition that I have at GUADEC. For a long time I did clutter talks, and now I started with a new kind of, again, therapy. So I started in 2015 saying, guess what, no more clutter. In 2014 I kind of reassessed and I said, well, let's start with the design of the new scene graph. And now I can actually present some of the scene graph. So yeah. So if you were wondering, this is the sum of pinpoint. It's been pointed out to me yesterday that by giving a talk, I started writing a presentation tool in order to write the library that was the subject of the talk. This is known as going full Pippin. So I've been told that this is bad and I should stop. So this kind of talk is geared a little bit towards the people that will probably use the new scene graph API in GTK, in the sense that there are going to be application developers more than toolkit developers. Why that is the case is the topic for another talk, but mostly boils down to the fact that inside GTK we will not be able to use immediately the scene graph API without for existing widgets. We will have to use it for new widgets, otherwise we break binary compatibility and then every application developer is sad and goes on main price. Which we don't want that. Not that much, at least. So if you use Clutter, for any particular reason, you are a shell developer, or you are a shell developer, or you are a shell developer, or you are a maps maintainer, I'm sorry for you. If you're a game developer, some games still use Clutter for, again, no apparent reason. But again, this talk is mostly geared towards people that have used Clutter before, or are still using Clutter, or they were planning to do something that involved a UI that is not buttons in grids with images and labels and text that are fairly constrained to the desktop use case. So I was actually going to say, have you accepted Clutter as your Lord and Savior? But I tried to. I knew that the presidential, that the Republican debate was on last night, and I wanted to just contain the craziness. So if you use Clutter, you know that there is a thing called actor, which is the base node, is the side-to-scene graph. It does mostly everything these days. Back in the day, it was a pretty poor copy of GTK widget, in the sense that it inherited all the craziness inside GTK widget and none of the useful things. So in an incredible amount of probably genius, I decided to call it layer. Then I realized that I used core animation far too many times, and yeah, that kind of stuck. So a layer is an actor minus the historical baggage of how many years now? 8 years of Clutter, plus the lessons that we kind of learned. I mean, there's a lot of historical baggage, but it's mostly because we kind of adapted the API over time. Because it was terrible before, it's less terrible now, and we can get it right if we just have 10, 15, maybe 20 years. It worked for X, right? Yes. Okay. So let's assume you want to write your own user interface that is not, again, strictly tied to the desktop use case. You start from GTK top level, which simplifies a lot of things, like you get the platform integration done right, at right level as well, and not a bad copy of bad copies of bad copies. You go to the widget that you want to use for your display. For instance, GTK drawing area. It's not necessarily GTK drawing area. It can be any widget at all. Custom widgets, your widget, the existing widget. You can even take a GTK button and add layers inside it if you want to. Why would you? Because it's cool. You call this function, which just tells GTK, hey, this widget will have layers inside it, so please take care of it. By taking care of it, it means GTK is now aware of the fact that it has to create a layer on demand when the developer asks for it, and it draws into it during the drawing cycle of any GTK widget. So it's integrated with the frame processing that GTK uses. It's similar to GTK widgets that as window. If you have any familiarity with it. And then that's it. You get your root. You get the layer, and you add layers to it, and it's done. That is the extent of the integration inside GTK of the cgraph API. It's the minimal amount possible. The actual commit that adds this stuff to GTK is ridiculously low. Ridiculously small. So now that you have a root layer and you add stuff, you realize that this is the top level of your scene. You basically just consider that as the sandbox out of which you cannot get out. You cannot just add layers to other widgets and then just go around. It's basically your container. Again, you go ahead and you build the scene as you would with Clutter, but instead of using the Clutter API, you actually have access to the entire GTK API and the scene graph API that comes with it. So I'll have to be boring and just give you some terminology. Every layer has a preferred size. It's usually the bounding box of the layer, so the rectangle that contains the layer. You cannot draw outside it. It's there. It's there for you. It's clicked already, and it all does the right things. But you can tell the layer by subclassing it. You can say, I actually have a specific preferred size. For instance, I do height for width management because that's easy. I do do width for height management because that's even easier. I do both. I do neither. Who cares? Then, like every widget has an GTK allocation, every layer has a frame. While the bounding box has the origin in the top left corner and it's 0, 0 by default, the frame has the origin as parent relative coordinates. So the frame is where your layer is in relation to its parent. So a parent would change things like the frame, the position, and other things, but not the bounding box. The bounding box is changed by the layer itself. Then we have a pivot point. Pivot point, if you are familiar with Clutter, is like the anchor point, but it's not insane. The anchor point was a mishmash, one of the, again, historical packages that came with iterating over the API for years. It's the center of transformation, but it also means that, it also implies that the position is a transformation. The position of the layer in regards to its parent is a transformation. This will come handy later, but in general, all transformations go through the pivot point, and the pivot point is slap bang by default in the middle of the layer. So if you want to have the usual case that everyone uses the anchor point in GTK in Clutter is, I want this actor to be centered with regards to its parent. This one does it by default. So you always position the center of the actor. You can change the layer. You can change the pivot point using normalized coordinates and from 0 to 1 in either directions. And then you can put it at 0, 0, and it behaves exactly like Clutter, or but behaves exactly like GTK or X. Or you can keep it center and it behaves exactly like coordination does. Again, coordination had a little bit more engineering time and effort to make the right choices. So I decided to kind of steal most of it. Again, center of the layer. The position, so the pivot point is in normalized coordinates, 0 to 1, 0 to 1. The position, though, is in parent relative coordinates, so it's in the actual coordinates. You say, I want this actor to be at 100 by 100. It's 100 by 100 in regards to the parent. And it's the position of the pivot point, not the position of the top left corner of the layer. That is one of the major changes in Clutter. There it is. Again, center of transformation, so rotation, scaling, everything goes through that. It's a it's a nice little way to tie up everything in one way so that you operate only on specific things without going crazy and saying, oh, I can move the position, but also I can do a transformation that undoes the transformation of the position. So why the position is a transformation? Because of invalidation. Every time you change the position of something inside GTK, you end up invalidating the geometry of that thing inside GTK, which means that you have to relay out the entire thing. GTK sometimes applies some smarts and says, no, there's no need to completely validate everything, but it's generally what happens. But we want each frame to be fast, and we cannot relay out every single frame. Changing the position of a layer does not imply a relayout. It just implies a blending, a new composition. Obviously, that is not always true. For instance, if you have a grid and you change the position of a layer inside a grid, obviously now you want that to be reflected inside the position of every other element inside the grid. So a layer can opt out of this and say, wait a minute, no, I want everything to, I want every transformation to affect my layout. One of the things we do to filter out this stuff is we bubble up every single change inside the geometry upwards to the root from the lower layer of the that said I need to be relayed out. But unlike GTK, and kind of unlike Clutter, we let every single parent intersect that. This means that by default, we don't relay out everything if something changed. For instance, a parent may be allowed. Let's say you have, typical case, an input box, label, entry, something like that. The size of the input box is fixed, but the children inside it might change relative size to each other. So there is no point in saying everything has to be relayed out when you know that the children will be the only ones affected. So the parent will bail out and say, I don't need to be relayed out myself. I don't need my parent to know that my size changed because my size didn't change. Only my children will change. So if nothing bubbled up to the root, then we only save the local changes and we affect the layout only on those parts of the graph. If you have any knowledge of how web rendering engines work, this is pretty much the same. The important thing is try not to get to the root. So try to block all the work that you have to do and try to minimize the invalidation. As I was saying, all of this can be opted out, and all of this is kind of by default not layout management friendly. You cannot have a GTK grid or a GTK box like GTK does, and because it will be short-circuited to death. The end result is that there are a bunch of places where you can have delegate objects like a layout manager that will intersect most of this stuff. And you can write your own GTK, the version of GTK box that you want, GTK grid, whatever, for the SceneGraph API. And it will work exactly the same. Another thing that we do for geometry changes is if the size changed, the contents change for obvious reasons, unless it doesn't. I know. For instance, you have a widget a layer that grows, but the contents just stay at the center, for instance. Or you have a layer that shrinks, but the contents stay exactly the same because it's clipped. But if the content changes, it means that we are redrawing the same. But it doesn't necessarily mean that it's what happens all the time. GTK, again, this happens all the time. If you have to redraw something, it will redraw the entire thing. That's why we have things like the pixel cache inside text view and other like small optimizations here and there. Well, small pixel cache is huge. But if the size did not change and the content did not change, then the contents of the layer are exactly the same. You don't have to redraw them. You just have to redraw them at the right position using simple Cairo or GL operations. And those are fast. Moderately so, at least. So the content means the stuff that is inside the layer. Maybe text, maybe image data, maybe a background color. Like the layout management, changes in content can get intercepted by the parent. For instance, the parent can have a cache inside itself and decide not to redraw, not to go up to the entire, walk the entire graph. So we are now to the point of layer state. So we have two states. One is the model, the layer as you want it to be. The presentation is the layer as it will be drawn on screen. Those are the two specific states that we have. And you also have a bonus state, which is used during animations. So the presentation is going to be a linear interpolation between the initial state and the final state. But that is, again, the presentation layer, which is read-only. Again, it's easier to deal with that, especially if we want to thread it off. Everything gets cached, and if the graph is stable, the scene did not change from one frame to the other. Well, or at least it changed in some spaces, in some places, but not everything. Then we just need to recompose it, and that again is fast. Yeah, this like the layout manager, you can delegate the content drawing. And we get to the other part now. Okay, this is the animation part. This is not completely done yet. I managed to break it this morning. Go me. Yeah, it was either finish this or fix the animation. And this one won. So each layer has its own presentation time, which is the time when it was drawn first. And it follows the scene graph as well, so that every child will inherit the time of the parent. So if something changes inside the parent, all the children get updated using the correct time. But also if a child has an animation, they will be animated at the same time. The time starts when the layer is drawn first. Again, we interpolate the initial state with the model state. So where you are, where you started, where you want to be, and the animation is just presentation going along that line. We only do this for animatable properties. We don't do this for all the GeoJet properties. We tried that with Clutter animation. Let's just say it doesn't scale. It's pretty bad in terms of performance because you now have to deal with boxing and unboxing GeoJet properties every 60 milliseconds. Let's say that, I don't know, you blow up 8 milliseconds because boxing boxed value, like a matrix, now takes a lot of time. Then you blow off half of your frame budget, and you start losing frames, and it starts to suck, and you don't want that. So I decided to go with something that I mutated from Clutter, one of the recent-ish changes, which is the easing state. Every layer has its own easing state, which is a combination of duration of the transition, the easing mode, the curve of the transition, and the delay if it starts with after a while. instead of starting right when the layer is drawn. DC state is stackable, so you can start one, and then you can modify the state of the actor, modify the state of the actor, modify the state of the actor, and everything gets compressed and drawn. And you get notification when animation starts and stops. This one might not be. I'm still kind of trying to figure out if there is a good. I don't know what to say. I mean, if there's a good case for explicit transitions, so an explicit transition is literally set all these properties at these values and then just start the transition and don't notify me and whatever. I'm doing this stuff as a separate object. If you are familiar with tweener in JavaScript or Flash, that's pretty much all that is. So at the end of the day, GSK, the scene graph toolkit, is clutter minus historical baggage plus all the ancillary. That doesn't mean that the story ends there. As I said, all of this stuff is done with the core API, so it's missing the animation. But the core API is already there. But we also have something to do post-merge. So maybe more layer types, because right now there is only a single layer type, the neutral, transparent GSK layer, which doesn't do anything. It tells you, it basically gives you all the tools to draw yourself. A scroll area, probably, something that automatically scrolls to a point with interpolation stuff, does clipping to the layers frame and some other interesting things. Very simple text display, probably, using Kai or Pango. No editing. Really no editing. Editing means craziness and input I'm not going to touch. I'm waiting for Carlos to fix it. Image content. So you can take a file, GK pixbuff, because we still have to deal with GK pixbuff. Probably a Kara surface D, and just draws it at a specific point in a specific position in the window. So you can do icons and stuff like that. Maybe add some layer manager delegates, like grids, boxes. I honestly don't like them, so I don't think I will. But if somebody wants to rewrite the GTK box allocation algorithm for the or fourth time, I think it is. Probably fourth time. You'll feel free to do that. I'm not going to stop you. In-testing, which is kind of important as soon as you start doing things like input with on the scene graph itself. You don't want actual input like button press event, button release event, stuff like that. But you do want things like what is the layer at these coordinates? How can I get the position in the scene graph? And do like simple transformations and stuff. This one is a pretty big thing, and it's also a hard thing. It's an integration with GTK Builder. Sadly, GTK Builder lives in GTK, which means that all the smarts to create stuff have to go inside GTK and not GSK. The layering is GDK, GSK, GTK, and you cannot access stuff from one to the other. Well, you can only access from the top to the bottom. No, the other way around. Not fun. Mostly because all the stuff inside, all the custom handling in for buildable classes are inside the classes themselves. And if they don't have access to GK Builder interface, then This one is another hard one. This is something that I really, really want because I love layout constraints. They are fairly hard to do right. You can do a naive thing and then die by 1,000 paper cuts. But if you read interesting comp sci papers on how to solve multiple systems of multiple linear equations, then you can get them to do stuff really neatly and not really slowly. An OpenGL layer, mostly because at some point we will want to draw GL stuff now that we can. And this one is the opposite of the get layer call, which allows you to take a GDK widget and put it into a layer. So it's basically another GDK. It works by saying, take all the drawing calls that you do on this widget, and instead of doing them on a GDK on the Cairo context that the GDK widget provides you, we do it on a Cairo content that GSK provides. And all the input gets redirected and connected to the right places, and craziness ensues. But that is basically it. GStreamer GDK is another thing that I know is fundamental to basically drop clutter from the platform, from the application development platform. Because right now, basically everyone that uses clutter uses it to draw videos and widgets on top of videos. Now that GStreamer has a GDK integration, a widget that uses GL and other things to draw, it's probably going to be easier to do this. So the actual question, though, is what do we need to port? And when do we need to port it? So before or after this? Past experience, lots of past experience, tells me that even if we decide to say, okay, let's release GK4, job done, before people will start porting their stuff, it's going to take a long time. So trying to be as compatible, as binary compatible and API compatible as possible to GTK3 is key. This means, though, that we will not be able to port our existing GTK widgets to the new Graph API, because otherwise, again, we break binary compatibility and Q for Onyx titles that say GTK is dropping everything, and they all suck. So, I try to be as fast as possible. I have a bunch of other things that I can discuss. I will be around until the 12th anyway. So if you want to stop me, like if you see me and want to stop me and want to talk about this stuff, just feel free. I'm approachable and huggable. Yeah, question? Well, okay. The question is the code somewhere? Yes, the code is somewhere. It's on my GitHub tree because I'm a serial rebaser, and you cannot really follow my development phase. But now that the core has stabilized to the point where I actually could make this and not try to stab myself in the eyes, I will compress everything and then start pushing to gnome.org as the default one. And do topic branches on my GitHub anyway. But yeah, this one, also the small tool that I use to write this presentation is going to be in GitHub as well.
So hi, great work. How similar to Cluster is this? Would a porting guide make sense? Say you want to port like a map widget.
Completely unrelated. A porting guide makes total sense. The API is pretty close. To the point where I basically, at some point, copied and pasted and then replaced inside DIM. But the implementation has some gotchas. Also, since you're using like low-level stuff like Coggle probably, Champlain does at the very least. No, that won't be possible. Lucky for you, all you do is basically just draw some tiles around. So that's probably going to be easier just using Cairo. So for you, it's pretty much, I think it's going to be like not a mechanical part, but it's going to be easier than a lot of stuff. Porting the shell, for instance, is basically impossible. Porting games is probably trivial, literally almost a mechanical thing. Again, if somebody's using Coggle, then you're on your own and you suck. There's a question over there.
So you mentioned it's hard to integrate with GTK Builder because of the direction of the stack.
Yeah.
Do we need another layer? Is there any reason this couldn't just be in GTK?
Oh, you don't want GTK Builder in GTK because that would be a massive layer in violation. But you might want something like Builder inside GIO.
No, I mean, could all the scene graph stuff just go straight into GTK?
Oh, no. I really don't like that idea. I prefer to have it as a separate entity, mostly because not everyone will need it. So it's kind of pointless to just have it. Okay, the API surface of GTK is huge. Adding another bunch of things that are pretty like orthogonal to GTK, it's kind of bad. People will start saying, okay, how can I use a GTK layer? Why is it GTK layer and not GTK widget? Is this a new root? Is this a new toolkit? What's the API? Instead, if we put inside a separate library, then people will treat it as, okay, there's a GTK window, which is the native surface where you basically get input and draw. There's the scene graph API, and there's the GTK, and they all like interconnected. Also, the namespacing is different, and so that it clearly has a separation, a mental separation of what you do and what you use for each part. Also, because in the future we want to be able to drop a lot of GDK and to use as much as possible as GSK inside the toolkit itself. So I'm wary about overloading GDK with too many base classes.
Any other questions? You mentioned that porting the shell would be more or less impossible. It's also recommended path forward for organ shell to keep it forever, or is there another path you think?
Well, it will have to keep Clutter forever as long as forever equals 3. If you want to, in order to write a new compositor using this API and dropping Clutter, you will need to have a GDK backend that draws directly onto your frame buffer, that listens to input using the libinput stuff, and actually depends on systemd. Funny thing, I kind of started writing that just because I want to see what happens when I say GDK now depends on systemd. Troll level Leonard. So, but after you've done that, and you basically move a bunch of stuff that is currently inside Mother inside GDK, and you can write a compositor using GDK and GDK, obviously Clutter is not needed anymore. Then you can use GSK, fine. But now you have to write the entirety of no shell, basically from scratch. There is no parking involved there. It's too low level, it's too messy, it's too... Also, all the extensions that we all use and love. I'm kidding, Alan. No, all the extensions will have to be dropped completely, which would go down really easily with the user base. Awesome. But yeah, basically you'd have to rewrite the entire thing, which is entirely possible, as far as I'm concerned. Considering the amount of resources going into GNOME Shell, I don't think that's gonna happen. One of the things that the GNOME Shell developers can do is literally import Cobol and Clutter inside the GNOME Shell repository and start hacking away all the stuff they don't need, which is lots. And that is a way forward. Clutter and Cobol become two internal libraries like SD does. By the way, all this stuff is drawn using, just because I didn't know that Benjamin would not be here, but I did that only for him. This entire thing is drawn using the style API from GSK. If you want to see really, really ugly code, where is it? Fine. Yes, fine. How do you zoom in? Control Shift. Yes. So as you can see, I'm just drawing the layer using GDK API. It's just using the CSS stuff. And that's it. So it's already integrated, you can already draw this. You can even make it look like a button. Except it will not work like it at all.
So we have a break now, I think of around 15 minutes, or was it lunch? I think it's actually lunch, okay, so we've got lots of time until the next talk.